All right, the last section here is inflation, appreciation, and depreciation. Now, first of all, inflation, that's the measure of how much the cost of goods increase by. So you've heard about, the price of bread was this much in this year, but it's gone up to this much in this year, or gas or whatever. Normally, this is given as a percentage per year. Appreciation is the increase in value of an item over time. So you buy some kind of collectible, and 5 years later it's worth more money. That's appreciation. Either way, the values are going up. You're going to do them in the calculator or by hand the same way. Depreciation, though, this is how much the value decreases over time. Things like computers, cars lose value as time goes on due to wear and tear, due to technology becoming out of date, whatever. So you say that they depreciate over time. Now, you can either do this with the calculator or with the compound interest formula. If you use the compound interest formula, and you're doing depreciation, you need to put your rate in as a negative because you're losing that value over time. Don't subtract it from 1 the way we did with our sequences before. That was a little bit of a different scenario. So you put it in as a negative. And your K value is going to be 1 because you're doing this, there's no compounding, okay, so it's just 1. If you're doing it by hand, your K value is 1. In the calculator, your PY and CY would be 1. The formula here, okay, that we did before back in section 5, if we put in a K value of 1, it becomes this, and again, negative if we're doing depreciation. Okay, so your book pretty much does this in the calculator, so we can do it like that. That's up to you, or we can do it by hand. Now, I'm not going to really show you how to put this in the calculator. Again, I'm going to write down what we would put in the calculator, but I don't think you really need to see me do that. So in this case, we've got an industrial dishwasher purchased for 2,400 pounds and depreciated by 15% each year. Find its value after 6 years. Then tell by how much has the dishwasher depreciated. Okay, so in this case, with all this appreciation, depreciation, inflation, you're not going to have to multiply to find your N. It's just going to be how many years you're doing. So this is going to be 6. My percent, though, we're depreciating, so that's going to be a negative 15. The present value, just like before, we're going to put that in as a negative. No payment. The future value, that's what we're solving for, so leave it blank or put a 0 in there. And then the PY and the CY, again, those are going to be 1 because we're just doing this annually. Okay. Now I'm going to kind of do an arrow here just to show that that's what we're actually solving for. Okay, so in the calculator, you'll go to your FV, and you'll hit alpha and enter on that. Let me actually just do one of these, just in case you have forgotten how to put these in here. Then I'm not going to bother doing the rest of them. So we've got 6, negative 15, negative 2,400. No payment. We're going to be looking for this, but put a 0 for now. 1 and 1. Okay, so back up to your future value. Hit alpha and enter. Okay, so $905.16, or sorry, pounds. So 905.16. Now we'll come back up to the by hand here in a minute. To find the depreciation, we're going to take the original minus the 905.16. So rather large depreciation here. Now, if you were going to do this by hand, your future value would be 2,400. 1 minus, okay, your R is 15%, and it's minus because it's depreciation, over 100, because your K value is 1, because we're compounding essentially annually. So then my exponent here is going to be 6 times 1, which is just 6. So type that in your calculator, and you get the exact same answer. For as far as your homework, maybe kind of jump back and forth, do some of them by hand, do some of them with a calculator, because I do want you to know how to do it either way. Okay. All right, next, we have a vending machine that was bought for $15,000, sold 3 years later for 63.6% of its initial value. Calculate its annual rate of depreciation. All right, so we've got 3 years. I don't know the rate of depreciation, so that we're going to solve for, but again, we'll put 0 in for right now. The present value is negative $15,000. No payment. Okay, future value. The vending machine is bought, sold 3 years later for 63.6% of its initial value. So to find my future value here, I'm going to take my initial value times 0.636 and end up with 9,540. Now, if it says that it lost a percentage, then you would subtract that percentage from 100, but it says that it was actually sold for that amount. Okay, and then 1's for everything else there. So this time, again, we're going to be solving for our rate. So we end up with a rate of 14.0%. Now, this is probably not one you'd want to do by hand, but if we did, here's my future value, here's my starting value. Subtract because it's depreciation. And then you can solve that by graphing. You can either divide both sides by 1,500 before you do it, or you can set this side equal to this side, and either way you'll end up with the same answer. All right, a couple more here. So a collectible is bought for $100 and its value 3 years later has increased 60%. Calculate its annual rate of appreciation. So this is a very similar question. 3 years. I don't know the interest. We're going to solve for that, but put 0 in for now. Present value is $100 as a negative. Sorry, I just wanted to check here real quick on the last one. Yeah, I want to make sure that I remember to put a negative on the last one there. Present value is always going to be negative. Payment, no payment. Future value, okay, so $100 increased 60%. Now this one should be pretty obvious that you're not going to multiply by 60 because if you do, you end up with 60. And the price should go up. So if it's increasing 60, it's going to be worth 160%. So times 1.6, my future value is 160. So we end up with an R value of 17.0%. We're not always rounding off to 0.0. That's just the way both of these worked here. By hand, similar kind of setup from the last one. This one, though, is positive because the price is going up, not going down. And again, solve by graphing. Either divide both sides by 100 to start off with, or just set both sides there equal to one of your y's. All right, next. If the inflation rate in Canada this year is 2.35%, calculate the likely cost of a $750 Canadian laptop computer 4 years later or 1 year later. Okay, so we're going to fill these numbers in here twice. For our 4 years later, our N is 4, 2.35%. Our present value, negative 750 with no payment. Future value, I don't know that one, so we'll leave that as 0 for now. 1's down the way there. Okay, so we go back up, we solve for that future value. We end up with $823.02 Canadian dollars. By hand, 750, 1 plus 2.35 over 100 to the 4th power, okay, because we are doing it for 4 years. Just make sure that decimal place is obvious there, okay? All right, now, what about 1 year ago? You're going backwards. So in this case, you're going to change this 4 to be a negative 1. Okay, so this is for part A, this is for part B. So ahead of time, positives, backwards in time, negative. Now when you do that, you end up with $732.78. Now think about that, does that make sense? So the price, it's inflation, the price is going up. So if I go back a year, okay, we were starting off with 750. So if I go back a year, it's going to have to be lower. And yeah, it's lower. Okay, so that's kind of weird. and I wanted to make sure that you were cool with that. Okay, last one. We have Jose, runs a printing business in Chile, decides to buy a new printing press at a cost of 4,500 pesos. The value of the press depreciates at a rate of 10% each year. How long will it take before the press is worth half the amount he paid for it? Okay, so we're looking for in here. Okay. The interest rate is going to be -10 because we're depreciating. Present value, -45,000. No payment. Future value, okay. How long will it take before it's worth half the amount he pays for it? So 4,500 divided by 2 gives me 2250. So 2250. One's for everything else. Go back up there and solve for that n. Remember, you would have to put a 0 in it to let it get you further on down there. And we end up with 6.6. Now, in this case, we don't have to worry about dividing by how many times we were or how many times we were compounding, because we're not compounding. I do want to just double check something though on this one, because I don't remember the way this one turned out. So let me put these in here real quick. 0, -10, -4,500. I want to make sure that I rounded this one correctly. And then back up to the top, double check that I put everything in there correctly. Okay, alpha, and enter. Okay, so 6.57, this one would round up anyways, but if this was, say, 6.52, you would need to round it up because 6.5 years wouldn't be enough. You would have to go up from there. Okay. Now, again, if you were going to do this one by hand, 2250 is equal to 4,500. 1 minus 10 over 100 to the x power. Now you can simplify what's in the parenthesis there, but you don't have to. That's up to you. And then, like I said, either plug in this for one y and this for the other. Or if we divide both sides by the 4,500, we can have this. And that might be a little bit easier for you to graph, because then your window's not going to need to be as big. In this case, I'm looking for where it's going to cross a y value of 1/2. Whereas on this one, I'm looking for where it crosses a y value of 2250. Okay. All right, so that's it. And we'll start doing our review for the next class. But for today, you're finishing 7-7. So like I said, you can use the calculator. That's what the book does for pretty much the entire thing, if not the entire thing. But I would maybe kind of jump back and forth and maybe just make sure you can do it by hand as well. But I'm not going to count off if you just use the calculator. Just make sure you give me that list of the numbers that you were plugging into the calculator.